Good morning, students. In continuation with the last class, we have solved number of problems including the previous question paper problems. And also at the end of the last class, I concluded how to calculate the torque in case of epicyclic gear train. Now, today I will solve 4 more problems, that too from previous question papers, where not only the speed of any gear or the wheel in a given epicyclic gear train, in addition to that, how to calculate the torque, that will also be discussed. Now, taking first one, an epicyclic gear train consists of a sun wheel S, a stationary internal gear E, and 3 identical planet wheels P, carried on a star-shaped planet carrier C. The size of different toothed wheels are such that the planet carrier C rotates at 1/5 of the speed of the sun wheel S. The minimum number of teeth on any wheel is 16. The driving torque on the sun wheel is 100 Newton meter. Determine number 1, number of teeth on different wheels of the train, and the second one, torque necessary to keep the internal gear stationary. Now this is a epicyclic gear train, consists of one is sun wheel S, which can be seen in the figure. S is the sun wheel, and internal gear, one stationary internal gear, that is means fixed internal gear E, and there are 3 identical wheels, planet wheels, which are named as P. And these identical planet wheels are carried on a star-shaped planet carrier C. Now the size of the different toothed wheels are such that the planet carrier C rotates at 1/5 of the speed of the sun wheel. Therefore, in the given thing, based on this sentence, what is this sentence? Planet carrier C rotates at 1/5 of the speed of the sun wheel S. So carrier is C. So if it is rotates, means speed of the carrier NC is equal to 1/5 of speed of the sun wheel, that is NS. NS is the speed of sun wheel, NC is the speed of the carrier. Therefore, speed of the carrier is equal to NS by 5 with this sentence. And second thing is the minimum number of teeth on any wheel. Here how many wheels are there? One is sun wheel S, the second one is internal gear E, and the third one is a planet wheel. So on these 3 wheels, the minimum number of teeth should be 16. 16 and above is allowed. That is what the understanding or meaning of this sentence. Minimum number of teeth on any wheel, planet wheel, sun wheel, and internal wheel E. So on these 3, this is the condition. Next, he has given the driving torque on the sun wheel, means the torque which is exerting or which is developing in the sun wheel is 100 Newton meter. So torque is nothing but force into radius. That is why new units are Newton meter in SI. So determine number of teeth on the different wheels of the train. So I should determine number of teeth on the sun wheel S, that is TS, number of wheels on the planet wheel, that is NP, and number of teeth on the internal gear E, that is NE. So I should find the number of teeth on all the 3 wheels. And second, so how much torque is required in order to keep the internal gear stationary? Means what is the internal gear, stationary internal gear? E. So in order to keep this internal wheel stationary, how much torque is required? So that we have to calculate. First, so let us complete a tabular method. First, let us get ready with the table. Now, in the table, so as you all know that first column is step number, second is conditions of motion, third is revolutions of elements. Now under the revolutions of elements, now I should enter the different gears which are there in the given epicyclic gear train. Now here, so till now in all earlier problems we have come across the R, where we used to assume as fixed. But here in this, a carrier C which is carrying the three identical planet wheels should be fixed. So once the carrier C is fixed and sun wheel is rotated, sun wheel will be given a revolution. So thereby planet carrier is C, that is first. Second is the one for which we are going to give the revolution. So that is sun wheel S. As the sun wheel is rotated, so the planet wheels which are in mesh with the sun gear will rotate. Therefore, next one is planet wheel P. And as the planet wheels P rotates, the internal gear E will also starts rotating. Therefore, the priority and the order and the sequence based to prepare the table is here. Instead of the arm, there is a carrier which is carrying the three identical planet wheels should be fixed. Next, give the rotation for the sun wheel S. Once the sun wheel S rotates, P starts rotating. Therefore, next is planet wheel P. And as the planet P starts rotating, it drives the gear E. Therefore, internal gear E is the last under revolutions of column. So like that. So first, first step, planet carrier C is fixed and give rotation for the sun wheel S in anti-clockwise direction by one revolution. Therefore, write down in the conditions of motion planet carrier C fixed and sun wheel S given +1 revolution. So planet carrier is fixed, therefore it is 0, and sun wheel is rotated by 1 revolution in anti-clockwise. According to our sign convention, it is plus, therefore +1. So once the sun wheel rotates in anti-clockwise, the planet wheels P starts rotating in opposite direction because sun gear and planet wheel are in mesh with each other externally. Therefore, sun wheel is rotating in anti-clockwise, so planet wheels will rotate in clockwise. Therefore, according to our sign convention, it is minus. But what is the speed of planet wheel? That is ratio of number of T's on the sun wheel by number of T's on the planet wheel, that is Ts by Tp. I am finding the speed of wheel P with respect to wheel S. Therefore, speed of the planet wheel is equal to previous minus current, that is Ts by Tp, and it is in clockwise. Therefore, according to our sign convention, minus. So minus Ts by Tp will give you the speed of the speed of the planet wheel P. Next, the planet wheel P rotating in clockwise, and it is in mesh with gear E internally. Therefore, in what direction the planet wheel rotates, in the same direction the wheel E starts rotating, means in the clockwise direction. Therefore, again minus I wrote in the internal gear cell, minus now. So Ts by Tp previous into now Tp by Te. Therefore, TP gets cancelled. I will get minus TS by TE. So like that, I should complete the first row of the table. Then go to the second step. Once again, what is the condition of motion in the second row? Planet carrier C, still it is fixed. Now the sun wheel S, which was given plus 1 revolution, to be given now plus X revolution. It means I should multiply all the first row values with X. So 0 into X is 0, 1 into X is X, minus Ts by Tp. If I multiply with X, then it will be minus X into Ts by Tp, and minus Ts by Te. If I multiply with X, then it will be minus X into Ts by Te. Next, go to the third step. Add plus Y revolutions to all the elements. So plus Y, plus Y, plus Y, plus Y. For all the 4 elements. Now find in the fourth step total motion of all the elements. Total motion of the elements. So here, to find the total motion of the element, I should add the value of second and third of that element. So what is the second row value of the planet carrier C? 0. What is the third row value of the planet carrier C? Y. If I add second and third, 0 plus Y is plus Y. So X plus Y, like that for sun wheel, X plus Y. So Y minus X into Ts by Tp, Y minus X into Ts by Te. Like that, I should complete the table. Now look at, as we know that the speed of the planet carrier, NC is equal to NS by 5. Or from this I can write NS is equal to 5 times NC. Now what he is saying, when sun wheel makes, according to this, when sun wheel makes 5 revolutions, the planet carrier C makes 1 revolution. Because, so therefore, so NS is equal to 5, that is equal to 5 into NC. So NC is equal to 1 revolution. That is what the meaning of the given thing in the problem. But from the table, one can write the total motion of the planet wheel carrier, that can be get from the last row, that is Y. So speed of the planet carrier C from the table, NC is equal to plus Y, that is equal to, now I can write 1 revolution. And from the table also the speed of the sun wheel is equal to X plus Y. Therefore NS is equal to X plus Y, that is equal to 5, because NC is equal to 1 revolution, NS is equal to 5. So X plus Y is equal to 4. I know Y value. So if I substitute, I will get X is equal to 4 and Y is equal to 1. This is one condition which I got based on the statement. So what is the statement says? The planet carrier C rotates 1/5 of the speed of the sun wheel. That is nothing but whenever the sun wheel makes 5 revolution, the planet carrier makes 1 revolution. That is the exact and clear-cut meaning of it. So from that, I just got NC is equal to 1 revolution and NS is equal to 5. So with that, I got X is equal to 4 and Y is equal to 1. And one more condition, if I read the statement of the problem, I can identify the internal gear E is stationary, means gear E is fixed. That is nothing but speed of the gear E is equal to 0. That is NE is equal to 0. But from the table, what is the speed of the internal gear? That can be get from the last row of the table. That is speed of the gear E is equal to Y minus X into Ts by Te. So NE is equal to this from the table, but as the wheel E is fixed, therefore NE is equal to 0. By equating both, I can write Y minus X into Ts by Te is equal to 0. Now Y value is known 1 and X value is known, but I don't know the number of T's on the S and number of T's on the wheel E. So from this what I can write? So this minus 4 Ts by Te, if I take it to the right hand side, then it will be 4 Ts by Te is equal to 1. From this, on cross multiplication, 4 Ts is equal to Te. Here I don't know the number of T's on the sun wheel and number of T's on the internal wheel E. But he is telling minimum number of T's on each wheel should be 16. Therefore, since the minimum number of teeth on any wheel is 16, let us take or assume that the sun wheel, the number of T's on the sun wheel, that is Ts is equal to 16. With that, now if I assume Ts is equal to 16, then Te is equal to 64. So like that, directly now I got number of T's I am fixing. Minimum should be 16. So I am going to fix the number of T's on the sun wheel is equal to 16. As a result, the number of T's on the wheel E will be 64. Then I should find what is the first thing. Number of teeth on different wheels. Here there are 3 wheels. Sun gear E, sun gear S, internal gear E and planet wheel. Now, by fixing the number of T's on the sun wheel S, where the minimum should be 16, I got the number of T's on internal gear E is equal to 64. But still I should find on one more wheel the number of T's. What is it? Planet wheel. So, to find the number of T's on the planet wheel, just look at the geometry of the figure. Look at the geometry of the figure. I can write pitch circle diameter of sun gear S plus 2 times the pitch circle diameter of the planet wheel. That is equal to diameter, pitch circle diameter of internal gear E. So from the geometry one can write. Now ds is equal to 2 dp is equal to dA. Since he has not given any statement like module A is same or module A is twice or thrice condition like that, what we have seen in the earlier problems. So when it is not given, by default one should assume that module A of all the gears is same. So if I assume, then I can write the pitch circle diameters are directly proportional to the number of T's. Then Ts plus 2 Tp is equal to Te. Ts I have fixed it as 16 and Te, with that I calculated 64. If I substitute Ts and Te value, I can get the number of T's on the pinion wheel should be equal to, that is Tp is equal to 24. Like that, with the table and the given conditions, I can able to calculate the number of T's on the different wheels of the train, that is Ts, Tp and Te. Now the second thing is torque necessary to keep the internal gear stationary. Now I should find how much torque is necessary to keep the internal gear stationary. Now internal gear is what? E. But he has given the driving torque on the sun wheel is 100. So he has given the torque which is on sun wheel. And he is asking how much torque is required to keep the internal gear stationary. Therefore, what I do, simply to find the torque on gear E, I will write the condition. So, kinetic energy dissipated by the each wheel, I will equate. So, that is torque on sun wheel S into angular speed of S. So, T into W. T is torque and omega is W. Here I did not wrote as T because we are taking the number of T's on wheels which we have calculated in all our problems notation as T. Therefore, wherever there is a torque, I am going to write torque only. So now I know the torque on sun wheel. I should calculate torque on E. So I should calculate torque internal gear stationary. So torque on sun wheel into angular speed of sun wheel, that is equal to torque on planet carrier, because I want the torque that is required or necessary to keep this internal gear stationary. Now S and C, S and P or S and C, because carrier itself is carrying all the three planet wheels. So I will write the equation: kinetic energy dissipated by the sun wheel is equal to kinetic energy dissipated by the planet wheel or the carrier, planet carrier. So torque on S into angular speed of S is equal to torque on planet carrier C into angular speed of the planet carrier C. So torque on S is given because the driving torque on sun wheel is 100 Newton meter. So 100 into angular speed means omega S. That is equal to torque on C into angular speed of C is omega C. Now here torque on C I will calculate, that is equal to 100 into omega S by omega C. That is equal to 100 into ns by nc I will write, because angular speed omega in general we know that it is 2 pi n by 60. Omega s means 2 pi ns by 60. Omega c is 2 pi ns by 60. If I substitute and simplify, omega s by omega c will be equal to ns by nc, because 2 pi gets cancelled, 60 gets cancelled. So omega s by omega c is nothing but ns by nc. That is equal to 100 into ns is the speed of the sun wheel, that is 5 rpm, and nc is equal to 1 rpm. So substituting I will get the torque on C. So now I got, he has given the torque on the sun wheel. Now I calculated how much torque on the planet wheels or the planet carrier. But I need how much torque is required to keep this internal gear E stationary. Therefore, that is equal to difference between the torque C minus torque of the sun wheel. So 500, that is the torque which is exerted on the planet carrier, and minus the torque which is exerting on the sun wheel. So 500 minus 100 is equal to 400 Newton meter. Like that we can calculate the torque. So second one, the figure shows an epicyclic gear train where the arm A is the driver and annular gear D is the follower. The wheel D has 112 teeth and wheel B has 48 teeth. B runs freely on P and D is separately driven. The arm A runs at 100 rpm and the wheel D at 50 rpm in the same direction. So find the torque on B if A receives 7.5 kilowatts. So I should find the torque on B. How much torque is required on the B? How much torque is required on B if the torque on A is 7.5 kilowatts? So now this is the figure. So if I list out the given things, wheel D is having 112 teeth, therefore TD is equal to 112. Wheel B is having 48 teeth, therefore TB is equal to 48. And the arm A runs at 100 rpm, so NA is equal to 100 rpm. Clockwise or anti-clockwise he has not mentioned, so directly 100 means it is plus 100, means we have to think that according to our sign convention anti-clockwise. And wheel D at 50 rpm, therefore ND is equal to 50 rpm. Both are in same direction. Now I should find the torque on B if torque on A is equal to 7.5 kilowatt, that is equal to 7.5 into 1000 because kilo. So then it will be 7500 watts. Now in order to find the torque, first I should get ready with number of teeth and I should get ready with the table. Two things must be ready, whether you are going to find the speed or torque, whether I want the speed of any wheel in a given epicyclic gear train, or whether I want the torque on any element in a given epicyclic gear train, one should remember that by default, whether it is required or not required, whether it has been asked in the problem or not, you should find the number of T's on all wheels, and second, table should be prepared. So if these two things are ready, then we can easily calculate if we want speed, only speed, or if we want torque, only torque, or if we want both speed and torque, both can be calculated. Therefore, number of T's and table is compulsory. So now in doing so, here how many wheels are there? There are 3 wheels. That is wheel B, generally we call it as a sun wheel, and planet wheels. There are 2 planet wheels which are named as C, and 1 internal gear D, that is D, and these and an arm A. So there are totally 4 elements. One is arm A, wheel B, planet wheel C, and internal gear D. So there are 4 elements, out of which I know, out of 4, for arm it is not required, only there are 3 gears or 3 wheels, A, B, C, B, C, D, out of which I know the number of T's on D, which is given as 112, and number of T's on B, which is given as 48. Still I need the number of T's on the planet wheel. So to find TC, if I look at the geometry, I can write the pitch circle diameter of wheel D, that is DD, is equal to sum of the pitch circle diameter of wheel B plus DC plus DC. So therefore I wrote it as 2DC, 2 times the pitch circle diameter of the planet wheel C. So, and here there is no statement whether the module is same or not. So by default, if it is not mentioned, so we have to assume that moduli of all the gears are same. Then I can write the pitch circle diameters are directly proportional to the number of T's when the modules are same. Therefore, DD is nothing but TD, that is equal to TB plus 2TC. TD is given, substitute as 112. TB is also given, substitute as 48. Only unknown is TC. With that, I will get TC is equal to 32. What is TC? Number of T's on wheel C, that is equal to 32. Like that, now among the 4, one is arm, leave it, remaining 3 are gears, and number of T's on wheel D and wheel B is given. With that, I calculated number of T's on the pinion wheel or the planet wheel C, that is equal to 32. So number of T's are ready now. Now let us go to the table. Draw the table and complete it. So first step, conditions of motion, revolutions of elements. Now look at here, as there is arm, I am going to fix the arm A, and obviously I will give the rotation for the gear B. Therefore next is gear B. So when gear B is rotated, it drives the gear C. Therefore third is gear C. Gear C drives the gear D. So therefore gear D. Like that, in the order, in the sequence, you must write down. Then first step, arm A is fixed and gear B given +1 revolution. So arm A value should be entered as 0 because it is fixed. In the gear B, I should enter +1 because I am rotating gear B +1 revolution. Means I am rotating gear B in anti-clockwise by 1 revolutions. Therefore +1. So then gear C, speed I should calculate. So B is in mesh with C externally. Therefore, in what direction gear B is rotated, in the opposite direction gear C will rotate. Means in clockwise. Therefore, minus. And what is the speed of gear C? That is TB by TC. TB by previous by current. So I am finding gear C. Therefore, that is present. Previous is gear B, which is in mesh with it. So minus TB by TC. So that is the gear speed. Minus Y clockwise. Next, C drives the gear D, and C and D are in mesh with each other internally. Therefore, C is rotating in clockwise. Therefore, C will drive the gear D in the clockwise direction. Therefore, gear D, for which also I should write it as minus. Minus, previous is TB by TC into now TC by TD. TC gets cancelled, then minus TB by TD gives the speed of the gear D. Like that, first row is to be completed. Now in the second row, once again A is fixed, gear B should be given plus X revolution. So means I should multiply all the first row values with X. 0, 1 into X is X, minus X into TB by TC, minus X into TB by TD. In the third step, I should add plus Y revolutions to all the elements. So plus Y, plus Y, plus Y, plus Y. Next, find the total motion. So just add the second and third row value of each element to get total motion. 0 plus Y is Y. X plus Y will be X plus Y, which gives for the gear B. For the gear C, Y minus X into TB by TC. For the gear D, Y minus X into TB by TD. Like that, the table should be completed. After table is completed, now what he is asking? He is simply asking that find the torque on B if the torque on wheel A is equal to 7.5 kilowatt or 7500 watts. Now, in order to find the torque on B, one should know the speed of the wheel B. Therefore, in order to find the speed of the wheel B, right, what I do, I will just read the statement again. In the statement, what he says, the arm A runs at 100 RPM. That is why I wrote it, NA is equal to 100 RPM. But what is NA? Speed of the arm A is 100 RPM. But from the table, what is the speed of arm A? Y, simply from the last row. So NA is equal to Y. Therefore, Y is equal to 100. Directly 1. Next, wheel D is rotating at 50 RPM. That is why I wrote it ND is equal to 50 RPM. So, but from the table, the speed of the gear D is equal to, from the last row, Y minus X into TB by TD. So, therefore, I can write Y minus X into TB by TD is equal to what? 50. Now, Y is unknown. Y that you can directly or simplify first this Y minus X into TB is 48, TD is 112, that is equal to 50. If I simplify, Y minus 0.43X is equal to 50. You call it that as equation 1. Now substitute the Y value which you got as 100 in equation 1. So substitute Y in equation 1, then it will be 100 minus 0.43X is equal to 50. With that, I will get X is equal to 116 and Y is equal to 100. Now from the table, right, so the speed of the gear B is equal to X plus Y. Now I know the values of X plus Y, substitute, you will get 216 RPM anti-clockwise. And next, find the torque. Suppose here I have calculated the speed of the wheel B, wheel C also. If you want, you can otherwise know. But I need the speed of wheel B, that I calculated. Next, find the torque on B if the torque on A is equal to 7500 RPM. Now, if you look at the figure, B is in, now he has given the torque on the arm, and he is asking torque on the wheel B. So therefore, what I do, so torque on B into angular speed of B is equal to directly, right, torque on A into angular speed of A. Now torque on B into angular speed of B is nothing but omega B, that is equal to torque on A into angular speed of A in notation is omega A. Now here torque on A is given, that I have substituted. Therefore torque on B, which I should calculate, is equal to 7500 into omega A by omega B, or that is equal to 7500 into NA by NB, because omega A is 2 pi n, omega B is 2 pi n. So therefore instead of omega A, I can write it as NA, omega B, I can write it as NB, because 2 pi gets cancelled, 60 gets cancelled, which you can see on side. That is equal to 7500 into NA, speed of the arm A 100 and speed of the wheel B 216. If I simplify, I will get 3472 watts. If I divide with 1000, I will get in kilowatts 3.472. See what I did here. So now arm A torque is given, arm wheel B should be. So directly equated the kinetic energy dissipated by the arm is equal to kinetic energy dissipated by the wheel B. Suppose if I want how much torque is required on the internal gear D stationary, then I need to find, I should be, now I got torque B, so I should calculate how much is the torque. Once again, T torque on B into omega B is equal to torque on C into omega C. With that I will get omega C. Now in order to keep this internal wheel stationary, what I should do, that is equal to omega C minus omega B, so that how much is the resisting torque that is required in order to keep the stationary can be calculated. But here what is asking, only torque on A is given, B should be calculated. So directly, so R is in contact with the wheel B, therefore just I equated kinetic energy of the arm. So T torque on A into omega A is equal to torque on B into omega B. So only I calculated this. Suppose if I want for D, so again I should go for one more thing. So omega torque on B into omega B is equal to torque on C into omega C. Then what I will get? Torque on C. Then once you get a torque on C and the torque on B, subtract both, you will get how much resisting torque is required in order to keep this internal gear D stationary. In that way you can calculate. Now the third problem. Right, problem number 3, continuation. Continuing the problem number 3. Figure shows an epicyclic gear train in which pinion A has 15 teeth and is rigidly fixed to the motor shaft. With this, I can list in the given things. Number of teeth on pinion A, that is TA, is equal to 15. And this pinion A is mounted on the motor shaft. Remember. Next, the wheel B has 20 teeth. So TB is equal to 20. Number of teeth on wheel B, TB is equal to 20. And gears with A. And also with annular fixed wheel E. Pinion C has 15 teeth and is integrated with B. So number of teeth on pinion C, that is TC, is equal to 15. The gear C meshes with annular wheel D, which is keyed to the machine shaft. The arm rotates about the same shaft on which A is fixed and carries the compound wheel BC. If the motor runs at 1000 rpm, find the speed of the machine shaft. So, if the motor runs at 1000 rpm, so the motor shaft, it is the speed of the motor shaft. So motor shaft on which gear is mounted? Pinion A. Therefore, speed of the motor or speed of the gear A, that is NA, is equal to 1000 rpm. Find the speed of the machine shaft. So I should find the speed of the machine shaft. And the second one, find the torque exerted on the machine shaft if the motor shaft torque is equal to 100 Newton meter. So first, here there are in the figure, except the arm, there are 5 gears: gear A, gear B, gear C, gear D and gear E. So gear A is one wheel, one gear. Gears B and C is a compound wheel, and gears D and E are the internal gears. Now first let us find out the number of teeth on gears D and E, because he has given number of teeth on wheel A, wheel B, wheel C as 15, 20 and 15. Now I should get ready with the number of teeth on the remaining gears. So how many remaining gears? Gear D and gear E. So to find the number of teeth on gear D and gear E, by looking at the geometry of the given diagram, I can write the pitch circle diameter of gear E is equal to pitch circle diameter of A plus 2 times the pitch circle diameter of the gear B. That is one expression which I can write. Second, the pitch circle diameter of gear D is equal to pitch circle diameter of gear E minus of difference between the pitch circle diameters of wheel B and C, that is dB minus dC. So assuming, as here there is no statement of whether the moduli is same or different, so one should assume by default moduli is same for all the gears. In doing so, I can express the pitch circle diameters in the form of number of teeth, because pitch circle diameters are directly proportional to the number of teeth if we assume or if the moduli is same for all the gears. Therefore, now TE is equal to TA plus 2TB. Substitute and simplify, I will get number of teeth on wheel E is equal to 55. And TD is equal to TE minus of TB minus TC. So substitute the values of TE, TB, TC, thereby you will get the number of teeth on wheel D is equal to 50. Like that, now I am ready with all the values of the number of teeth on the gears. Next, let us make the table ready. Now, if I look at the diagram of the given epicyclic gate train, one is R. By default, we assume that we are going to fix it. Fix the R. Second, I am going to give the revolution for the gear A. Therefore, in the table, first one is R, second one is pinion A, and pinion A, when it is driven, it drives the compound gear. So BC. Therefore, next is gear BC. Gear BC is driving the internal gear D. So therefore, gear D is next. Gear D drives the gear E again. So therefore, gear E. Like that, in this order, you please write all the elements clearly under revolutions of elements. Now the first step, fix the R and rotate the pinion in anti-clockwise direction by 1 revolution. That is, arm is fixed, pinion A is given plus 1 revolutions. Therefore, in the first row, for the arm, I will put 0 because arm is fixed. Then for the pinion A, I will write it as plus 1 because I am rotating pinion A in anti-clockwise plus. By how many revolutions? 1. Therefore, plus 1. So then the pinion A rotates the compound gear BC, one of the wheels of the compound gear BC, in opposite direction, because pinion A and gear BC are meshed externally. So pinion A is rotated in anti-clockwise, therefore compound gear BC will rotate in clockwise, therefore minus into TA by TB, that gives the speed of the gear C. How? Because one of the gear of the compound wheel BC, that is C B, is in mesh with A, therefore TA by TB is the velocity ratio and it is clockwise, therefore negative. Next, gear D. So to find the speed of the gear D, carry forward, because TA by TB is previous into, now TC is in mesh with D, so TC by TD. So TA by TB into TC by TD. This is the speed of the gear D, and gear D is also rotating in clockwise, because compound gear and gear D, compound gear BC and gear D both are meshed internally, therefore so clockwise. Gear D will also rotate in clockwise, minus. Next, gear D is in mesh with gear E internally, therefore gear E will also rotate in clockwise, therefore minus. So TA by TB into TB by TE, TB gets cancelled, then minus TA by TE is the speed of the gear E. Like that, first row should be completed. Next, second step, arm is fixed. Now the pinion A should be rotated by plus x revolution. Nothing but I should multiply all the values of the first row with x. So 0 into x is 0. 1 into x is x, minus TA by TB into x is minus x TA by TB. So like that you multiply all the values of the first row with x. So thereby for gear D, minus x TA TC by TB TD. So minus x into TA by TE is for the gear E. Next, in the third step, add plus y revolutions to all the elements, plus y, plus y, plus y, plus y, plus y. Then find the total motion by adding second row value and third row value of the element. So for the arm, second row value is 0. For the third row value is y. So 0 plus y is y, x plus y is xy, y minus x into TA by TB, y minus x into TA TC by TB TD, y minus x into TA by TE. Like that you add second and third row value of each element to find the total motion of each element. Now what I should calculate here, I should calculate speed of the machine shaft. So machine shaft is mounted, machine shaft on which gear is fixed? Gear D. Therefore speed of the machine shaft is nothing but speed of the gear D. That you can read it in the sentence. Gear C meshes with annular wheel D, which is keyed to the machine shaft. Annular D is keyed to the machine shaft. Therefore speed of the machine shaft is nothing but speed of the gear D. Now to find this speed, now by reading the statement of the problem, I can identify one condition. Wheel E, one of the annular wheel, that is wheel E, is fixed. Therefore speed of the wheel E, that is NE, is equal to 0. Right, because it is fixed. In the statement it is there. But from the table, what is the speed of the gear E? So therefore from the table, NE is equal to y minus x into TA by TE. That is equal to 0 because NE is equal to 0. Now I don't know the value of y and x, but I know the values of T and T. Substitute and simplify, you will get one equation, that you call it as equation number 1. Y minus 0.27x is equal to 0. Next, also one more condition what I listed out, speed of the motor shaft, or it is nothing but speed of the gear A. That is NA is equal to 1000 RPM. But from the table, speed of the gear A or pinion A or the speed of the motor shaft NA from the table is equal to x plus y. Therefore, x plus y is equal to 1000 RPM. That you call it a second equation. Now solve the equations 1 and 2. X plus y is equal to 1000, then y minus 0.27x is equal to 0. If I subtract, and I can get the values of x and y as 787 and 213. But speed of the gear D from the table, that is ND is equal to y minus x into TATC by TBTD. Just now I got the values of x and y, substitute, and I already know the values of number of T's on all the gears. On substituting each and everything which I know, I can get ND is equal to 36 RPM. That is the speed of the machine shaft, or it is the speed of the gear D, 36 RPM. So the value itself indicates it is plus. Therefore, in the bracket, write down anti-clockwise. After finding the speed, now he is asking how much is the torque exerted on the machine shaft, means on the gear D, if the torque on the motor shaft or torque on the A is equal to 100 Newton meter. So to find the torque on machine shaft, simply you just equate the kinetic energy dissipated by both the shaft, machine shaft and motor shaft. How to write? Kinetic energy dissipated by the machine shaft is torque on machine shaft into angular speed of machine shaft, T omega. Torque into omega. Of which shaft? Machine shaft. So torque on machine shaft into angular speed of machine shaft is equal to torque on motor shaft into angular speed of motor shaft. So now torque on motor shaft, which we have to calculate, into angular speed of machine shaft is omega machine. That is equal to torque on motor shaft. It is given in the problem as 100 Newton meter. So 100 into angular speed of motor shaft is omega motor. Now from this, torque on machine shaft is equal to 100 into omega motor by omega machine. So omega motor or omega machine, but in general omega is 2 pi n by 60. After cancelling 2 pi, 60, 60. So in place of omega motor I can write n motor, in place of omega machine I can write n machine. Or that is equal to 100 into speed of the motor shaft is nothing but speed of gear A. Speed of machine shaft is nothing but speed of gear D. Therefore 100 into NA by ND. So that is equal to 100 into NA is 1000 and ND is 36. If I simplify, I will get 2777 Newton meters. That is the torque on the machine shaft. Next, the fourth one, problem number 4. Figure shows an epicyclic gear train in which gear A having 44 teeth is rigidly mounted on the driving shaft. Therefore, if I list out the given thing from the first sentence, number of T's on the gear A, that is TA, is equal to 44, and this gear A is mounted on which shaft? Driving shaft. Therefore, speed of the driving shaft is nothing but speed of gear A. Next, it gears with compound wheel CD. So, gear A is meshing with compound wheel CD. Wheel C has 22 teeth and wheel D has 26 teeth. So, number of teeth on wheel C, that is TC, is equal to 22. Number of teeth on wheel D, that is TD, is equal to 26. C gears with A and D gears with internal wheel B. The compound wheel revolves freely on a pin which protects from an arm rigidly mounted on the driven shaft. So, arm is mounted on driven shaft. Therefore, speed of the arm is equal to speed of the driven shaft. The internal wheel B is fixed. Therefore, NB is equal to 0. And moduli of all the gears is same. The driving and driven shafts and the internal wheels are coaxial. Driving shaft rotates at 300 RPM. So, therefore, speed of driving shaft nothing but, in other way, speed of gear A, that is NA, is equal to 300 RPM and transmits 2.5 kilowatt. So, driving shaft power transmitted by driving shaft, or it is the power transmitted by a gear A. Therefore, I wrote it as PA is equal to 2.5 kilowatts, which is equal to 2500 watts, because kilo watts. 1000 I multiplied. So 2.5 into 1000 is 2500 watts. Now find speed of the driven shaft. So driven shaft on which element of the gear train is mounted? Gear E. Therefore, arm. You read it as arm. So speed of driven shaft or speed of the arm, that is NE is equal to what? Next, torque transmitted by the driven shaft or the torque transmitted by the arm E. And third one, fixing torque. By neglecting the losses, you have to calculate fixing torque or braking torque or the holding torque. Now let us first calculate the number of T's. So here out of the 5 gears A, B, C, D. So out of 4 gears. So I know the number of T's on the gear A, C and D. I don't know the number of T's on the gear B. To find the number of T's on gear B, from the geometry of the given diagram, I can write a pitch circle diameter of gear B, that is dB, is equal to pitch circle diameter of gear A, that is dA, plus pitch circle diameter of gear C plus pitch circle diameter of gear D. So sum of dA plus dC plus dD is equal to dB. Now from that TB is equal to TC plus TD into TD, because the module he himself in the statement given that module is same for all the gears, hence pitch circle diameter is of gears are directly proportional to the number of T's. So TB is equal to TA plus TC plus TD. So now I know TB is equal to 44 plus 22 plus 26. So if I add all I will get the number of T's on the wheel B, that is TB is equal to 92. So once the number of T's are ready, let us complete the table. So in the table, so step column 1 is step number, second column is conditions of motion, third column is revolutions of element. In the revolutions of elements, totally there are arm, gear A, gear B and compound wheel CD. So totally there are 4 elements. So first anyhow there is a arm E that I am going to fix by default. Therefore in the revolutions of elements, first one is arm E. By fixing the arm E, what I do, I will give a rotation for the wheel A. Therefore, next one is gear A. This gear A drives the compound gear CD. Therefore, next one I should write it as compound gear CD. This compound gear CD drives the gear B. Therefore, I should write finally gear B. Like that, all the elements should be listed in the order, right, under revolutions of element. Now the first step, arm E is fixed and gear A is given plus 1 revolution. Means what I am doing according to this condition, I am fixing the arm E and I am rotating a wheel A or the gear A in anti-clockwise by 1 revolution. Therefore, I wrote it here in the step 1 as arm E is fixed and gear A is given plus 1 revolution. So arm E is fixed, therefore 0, and for gear A plus 1 I will write, because anti-clockwise it is rotated, plus by how many revolutions? 1, therefore plus 1. Then this gear A rotates or drives one of the gears of the compound gear CD, that is gear C. Therefore TA by TC is the speed and it rotates in clockwise, because gear A and the compound gears are measured externally. So hence gear A is rotating in anti-clockwise. Obviously gear CD, which is being meshing with gear A externally, will rotate in clockwise. So minus. Then gear B next. So compound gear CD drives the gear B. Therefore its speed is TA by TC into TD by TB. So again this gear B is an internal wheel and it is meshing internally with the compound gear CD. Therefore, it also rotates in clockwise. Hence, I wrote it as negative. Next, second step, arm E is fixed and gear A, instead of plus 1 now, plus x revolution. Nothing but, students, what I should do? I should multiply all these first row values with x. So 0 into x is 0. 1 into x is x. Minus TA by TC into x is minus x TA by TC. So minus x into TA TD by TC TB. Next, in the third step, add plus y revolutions to all the elements. Plus y, plus y, plus y, plus y. Then find, in the fourth step, total motion. So how to find the total motion of all the elements? So you have to add second row and third row value of each element. So for arm E, second row value is 0. Third row is y. 0 plus y is y. X plus y is x plus y for the gear A. Like that, second and third one should be added. So y minus x into TA by TC. So y minus x into TA TD by TC TB. Like that. Now after completing the table, one should remember only the last row, because last row gives the speed of each and every element. Now what I should find here, there are three things. Number one, speed of the driven shaft or gear E, that is NE, I should calculate. So in the statement, as I already told, that gear B is fixed, therefore NB is equal to 0. But from the table, one can write the speed of the gear B, that is NB is equal to y minus x into TA TD by TC TB, that is equal to 0. And substitute all that number of teeths which we know except x and y. I will get equation 1, y minus 0.56 x is equal to 0. In addition to the gear B which is fixed, we also know that speed of the driving shaft or the speed of the gear A, that is NA is equal to 300 rpm. But from the table, what is the speed of gear A? It is x plus y, therefore x plus y is equal to 300. Now you call it this as equation 2. Solve equations 1 and 2. Y minus 0.56 x is equal to 0 is one equation. Second one, x plus y or y plus x is equal to 300. Subtracting 1 minus 2, I will get x is equal to 192. And substituting this x value in equation 2, I will get y value is equal to 108. Like that, I should get ready with, I should calculate the values of x and y. X and y. X and y with the given conditions. Now, what is to be found? Speed of the driven shaft or speed of the gear A. From the table, the speed of the gear E, arm E or gear E or arm E, that is nothing but speed of the driven shaft, that is equal to y, which is equal to 108 rpm. So 108 means it is plus 108, therefore I wrote it in the bracket as anti-clockwise. And next, second, torque transmitted by the driven shaft. So now I should equate the kinetic energies dissipated by the two shafts. One is driving shaft, another one is driven shaft. On driving shaft there is a gear A. Therefore, kinetic energy dissipated by the gear A is torque on gear A into angular speed of the gear A, that is omega A, is equal to the kinetic energy dissipated by the driven shaft. On driven shaft, which element of the gear train is mounted? Arm. Therefore, torque on arm E into angular speed of the arm E, that is omega E. Now, torque on gear A I can calculate because I know how much power the gear A can transmit. That is given as 2.5 kilowatt, that is 2500. So PA is 2500, NA is the speed, and NA is so 300, and TA we don't know, that is the torque on gear A divided by 60. If I simplify, I am going to get torque on gear A will be 79.6 Newton meter. So substitute torque on gear A as 79.6 into omega A is equal to torque on arm E into omega E. Now torque on gear E or arm E is equal to 79.6 into omega A by omega E. That is equal to, I can write it in terms of speed. Omega means angular speed. right? So it is in radians per second. So now omega is in general 2 pi n by 60. 2 pi, 60, 60. If I substitute and simplify, I will be remaining with, in place of omega A, Na, in place of omega E, Na. So now 79.6 into Na is 300 and Ne we calculated as 108. So that is equal to 221 Newton meter. This is the torque exerted on the arm or on the driven shaft. Now the fixing torque or holding torque or braking torque or the resisting torque exerted on gear B in order to keep it stationary. So torque on gear B is equal to simply torque on gear E, what we calculated, minus the torque on gear A, what it is given. So 221 minus 79.6, which is equal to 141 Newton meter. So like that, the torque can be calculated. So this completes the problems on epicyclic gate train. I have covered almost all varieties of problems, including the previous set of previous question paper problems also. But I would like to summarize that you must prepare in gear train theory part, that is what is gear train, and explain the classification of gear trains with neat sketches. And also one more is explain with a neat sketch sun and planet wheel. That is nothing but epicyclic gate train only. So that already it is there in the material. So these are the three questions I have listed out based on the contents which are prescribed in the gate train topic and as well as the questions that have come in the previous question papers. So what is gate train? Explain the classification of gate trains with a neat sketch, or he may ask separately, explain with a neat sketch simple gate train or compound gate train or reverted gate train or epicyclic gate. And one more question is explain with a neat sketch sun and planet gear or sun and planet wheel. That is there in the material, so that you can read. This is theory. And third one, you have to practice all the problems, including the problems which I solved on simple, compound and reverted. So more particularly epicyclic gate train. So where in epicyclic gate train, what actually till now in around 15 problems, whatever I solved, so 15 to 20 problems, whatever I solved. So you may be asked to find maybe speed or torque or both speed and torque. So you will come across to find the speed and torque. These are the two things that you can just refer all the 15 to 20 problems what we solved. Whether you may be asking simply a speed of any of the gear or the arm in the given gear train, or he may be asked to find the torque. So whatever is to be calculated, whatever he is going to ask, but one should get ready with first. If we find the problem on epicyclic gate train, right, first I should be, by default I should calculate the number of T's first, then draw the table and complete it. So these two things are by default, you must do it. Number of T's and the table, both should be ready. And third, based on the given conditions. So maybe some one wheel or one gear is fixed or arm is rotating. Like that, whatever the conditions you see, based on the conditions you must calculate X and Y values which are required. Once you know X and Y, you go for the findings. So first find the number of T's, then draw the table and complete it successfully without any confusion table. Then take the conditions which are given. With that you calculate X and Y. After that you calculate from the table whatever the speed is required, speed, or torque means torque. Like that the problem should be completed. Now today, apart from uploading this video, I am going to upload the study material of entire gear train till now, whatever, right from the first class to till today, whatever I have told in the form of PPT. I am uploading the PDF copy of the study material till now. And one assignment that is to be submitted on next Monday. By next Monday, you must submit the assignment. Any doubts, you please call to me personally and take a clarification. Okay? Thank you. Thank you, students.